on magnetic induction, it will make mention. No? So the lesson on magnetic induction will mention about Faraday's law. And we are going to illustrate Faraday's law, no? And use this illustration given by our PHET simulator. No? And to start that, no, let us have this set up. No? So actually, we can either choose two coils. No, in this setup, we can choose either two coils that no we can change from two loops, no, or two. So there's two turns here, no. So you turn the wire twice. The one below is I think not turned four times. So or there are four loops below or four turns, while the one above is two turns only. No? Now, what another setup is simply no a single coil with four turns, no, four turns. No? So what we will try to use is these two sets, no, and we will try to find out which one will probably no, make the bulb light brighter. No? Two coils or two winds, two turns or four turns. No? Now, aside from the coil of wire, we are given a bulb, which we can also now connect to a voltmeter. No? We can likewise connect a voltmeter to our wire there or to our bulb. No? And we can also click these field lines for us to see now the field lines of the magnet. No? So this is basically a magnet, which of course we can vary its poles. No? So we can change the poles of this magnet by of course clicking this. No? Now we are going to drag this magnet, guys, and insert it to one of the coil here. No? Now if we insert that in one of the coil, it's just like having no our previous figure kaina, no, that this one is outside, and even though we now place it inside the coil, then it does not really contribute to anything except when we try to move no the magnet inside, and that's the only time we can see a change no, to the bulb. Now there are four turns here while the one above has only two. No? So let's say we will try to put the magnet no, to the coil with only two turns. No? So if we try to move in and out the magnet, we notice that the bulb lights up, no, but not as bright as the one that is having no four turns. No? The one with four turns of coil lights much brighter. No? Did you notice that one? Again, no? The magnet has to be moved in order for you to see no, a significant change in the voltmeter or in the bulb. No? But again, no, the number of coils also allows us to see a lesser effect no, of current. No? So what does the magnet there do? Whenever you move it, no, then you produce current in the coil of wire. No? Now there's no current there initially because there's no battery. No? But the current is created whenever we move the magnet in the coil. No? Now, another way to simulate the effect there is by turning the poles no, very fast. No? So if we click this one and we are able to change the poles very, very quickly, no? Then we can probably produce something like a generator. No? So a generator could probably be thought of as a device that has several no, varied poles. And these varied poles, there is a coil there that spins or moves around this varying no, poles no, of the magnet very, very quickly. No? So if that coil will travel there very, very quickly, then we will be producing no, a much brighter or greater current. No? Now try to notice and transfer it below, no? And we will try to do it again. No? you'll notice that this one will light up much more brighter, no? When we, click, no, or change the poles of the magnet much more quickly, no? Okay, so do you see the point there of the discussion? So basically, that's what